Do you want to know how the idea of parallel universes was formed? In 1801, Thomas Young conducted a famous experiment which made scientists after him questioning it all. It's called the double gap experiment. We got a light source and a screen. We leave two gaps for light to pass through. Young observed that light has a wave-like feature, and when the light passes through the gaps, they interfere with each other and create a light and dark pattern on the screen. Instead of shining the light freely into it, what if we use a gun that fires one photon at a time? Do we see the interference pattern again, or should we see only two bright stripes on the screen? Surprisingly, there is still an interference pattern on the screen. We sent the photons one by one, but why do they still show the wave-like feature again? What did these single particles interfere with? To find out what gaps the particles went through, we use a sensitive camera and monitor the gaps. The camera reports that 50% of the particles pass through the left slit and 50% through the right slit. The exciting part of the story is here. When we set up the camera to see the particles, two light pattern lines were created on the curtain. If we turn off the camera, the interference pattern is formed on the screen again. What happened? Do the particles understand that they are seen? Realizing that being monitored changed their behavior?
I thought I told a pony tail.
That is, they no longer behave like waves? No one knows the answer so far.
I don't know.
It's so weird that if anyone could explain why this happens, they'd be awarded the Nobel Prize right now. Maybe you can find the answer. So get to work. It seems that particles can not only travel to the past and the future, but when they understand that they are under watch, they change from wave to particle state. Werner Heisenberg and Niels Bohr believe that the wave that precedes the curtain is not a physical phenomenon, but only a probability that the particle decides where to land on the curtain. This wave disappears when it reaches the curtain and becomes a physical reality. According to physicists, the wave function decreases. According to this, it is not possible to predict the state of a particle before it lands, as if the particle has all the possibilities in itself at the same time, and only when something happens, it chooses it. What is even more strange is that all those possibilities seem to be in contact with each other and coordinate their movements. What does this have to do with a parallel world? Hugh Everett said in 1957 that the wave function never decreases. That is, if the particle lands here on the curtain, it could have landed anywhere on the curtain. That possibility does not disappear. It only occurs in parallel state. It means all the other probabilities occur in other time axes. According to this, whenever a quantum state becomes two different probabilities, reality becomes two branches. Meaning anywhere in the world, any particle that reacts with every other particle, reality and history become multi-branched, and all these realities exist somewhere out there. This means infinite realities and infinite worlds and infinite versions of you. In which, maybe in one of these worlds, you are a president, an athlete, a teacher, or a science promoter. According to these, the parallel world is just now emerging with every big or small decision you make, or the reaction of particles anywhere in the world. Doesn't it melt your brain? This is just one example of a parallel world models. What kind of work and life do you think you have in other worlds?